So my dear students, today now we are going to start exercise 8.1. okay, now in this question what is given, the angles of the quadrilaters are in the ratio 3:5:9:13. So that's why we have taken, let ABCD is a quadrilateral where angle A is to B is to angle C is to angle D equals to 3:5:9:13. So let A equals to thrice x as it is given in the proportion, B equals to 5x, C equals to 9x and D equals to 13x. Now all of you, the angle sum property of a quadrilateral is what? 360 degree. So if you add all the angles of a quadrilateral, any type of quadrilateral, always you get 360 degree. So now we are putting the values and equalizing with 360. As we are adding, we are getting 30x equals to 360, therefore x equals to what we are getting? 12. Now by putting as what we have considered, after that we are putting the value of x and we are getting the respective value of the angles. So we have getting like this way. So this is the answer. And one thing I want to tell you to my students, that at this time through the mobile or through the video I can't share all the informations. Okay, so it is your duty to go through the book line by line. In I'm telling about the maths book particularly, and there you see so many informations are there in line by line. Okay, so you go through the line by line, so you will get more information. Now you see question number 2. In this question number 2, that what is given, it is a parallelogram given. It is a parallelogram given. In this parallelogram the diagonals are equal. AC equals to BD given, and you have to prove that this parallelogram, so this parallelogram is a rectangle. We have to prove that this parallelogram is a rectangle. Now as I have already discussed the unique properties of a rectangle. What is the unique property of rectangle? That all the diagonals are equal and each angle equals to 90 degree. As one property already they have given, so with the help of another property we are going to prove that it is a rectangle. What is that property? That property is each angle equals to 90 degree. So that we have taken two triangles. One is we have taken ACB, another we are taking BDC. Now AC equals to BD already given us, these diagonals are equal, and AD equals to BC, that is opposite sides of a parallelograms are equal, you know, and AB is a common side. So in that way these two triangles are congruent with the help of side congruency, and after that we can prove that angle B is equals to angle A, as they with the help of CPCT, congruent part of corresponding part of congruent triangle. Now but we know that sum of the adjacent angle of a parallelogram is 180 degree. So therefore angle ABC plus angle BAD, ABC plus BAD is equals to 180 degree. So as we are proving already these two angles are equal, and again we are proving that the sum of these two angles equals to 180 degree. That means each of them must be 90 degree. So similarly you can prove that other two angles are also, that is C and D, are also 90 degree. So hence we can prove that this parallelogram ABCD is a rectangle, as each angle equals to 90 degree and the diagonals are equal. So to solve these problems of this exercise, you have to know the properties properly. All the properties you have to know. Okay, now you see question number 4. As I have given this one first, the proof, that's note. Now question number 4, what is given? Show that the diagonals of a square are equal and bisect each other at right angle. So that means here square given, and we have to prove that the diagonals are equal and they are bisecting each other, and they bisecting each other perpendicularly, these two. So as you know that in a square 4 properties are there. So already 2 properties they have given, that is ABCD is a square, the diagonals as it is a square, and the sides are as it is a square, it already satisfy 2 properties, and more 2 properties it is given to prove. Since it is a square, so how we have written, since a square is a parallelogram, so hence in a parallelogram diagonal bisect each other. Therefore we are getting already A equals to OC and B equals to OD. Number 1 we have given here. Now in the triangle ADB and BCA, now which triangle ADB and BCA, these two triangles, okay, these two triangles, in these two triangles now we are going to prove these two triangles are congruent. So how we are proving that AD equals to BC, opposite sides of a parallelogram or opposite sides of a square, and B angle A and B, that is angle, this angle and this angle is 90 degree as it is a square. Then and AB is equals to BA, that is a common side. So these two triangles are congruent. So we can write that AC equals to BD with the help of CPCT, corresponding parts of congruent triangle. Now already we have proved that the diagonals are equal. Now we are going to prove that these diagonals are bisecting each other. Bisecting also we have proved. Perpendicularly you have to prove. For that again you have to take two triangles. Okay, now which two triangles you have to take? One is AOB, another is AOD. So you see here AOB, AOB, AOB and BOC. Two triangles we have taken. One is AOB and there is, sorry, it is little problem giving to see nice like that way. One is AOB, another is COD. Or which triangles we have taken? AOD. We have taken AOD. AOB. So these two, AOB and AOD. These two triangles we have taken, and we have written OB equals to OD, AB equals to AD, sides of a square. OB equals to OD, from 1 already proved that they are bisecting each other. AO equals to AO, common side. Therefore these two triangles are congruent, and in that way we have proved that angle AOB equals to angle AOD with the help of CPCT. So we have proved that angle AOD is equals to angle AOB. That means these two angles are equal. But you see it is a linear pair. These two angles, sum of these two angles equals to 180 degree because they are linear pair. So each of them equals to 90 degree. Hence you can write that AC is perpendicular to BD. So it is given here name 3. So we can write from 1, 2 and 3 we can conclude that diagonals of a square are equal and bisect each other perpendicularly. Hence proved. Now comes to question number 6. Question number 6, what is given? Diagonals of a diagonal AC of a parallelogram ABCD bisect angle A. Bisect, I think all of you know bisector means what? That is angle DAC is equals to angle CAB. These two angles are equal. Show that it bisect angle C also. That means these two angle you have to prove equal, and ABCD is a rhombus. Now how it goes, you see it. So to prove we have written proof. Since diagonal AC bisect angle A, therefore angle DAC equals to angle CAB. Okay. Now you see as it is a parallelogram given, so sides are parallel, so you will get alternative angles, corresponding angles, all this. Okay, here you will get all alternative angles. Which two angles are alternative angles? DCA, DCA and CAB. That means this angle equals to this angle. So we have written DCA equals to CAB, alternative angles. Now here you have written A, this is B and this is C. Again another pair also, this angle equals to this angle. These are alternative angles. So from A, B, C you can write that BCA. So we have proved that this angle equals to this angle. Again we have proved that this angle equals to this angle, and we know these two angles are equal. Therefore these two angles are also equal. So from ABC you can write that BCA equals to DCA. So AC bisect angle C. Now in triangle ABC, already we have proved that angle CAB is equals to angle BCA. These two angles are equal. From A and B we are getting these two angles are equal. So you see in angle in A we are getting DAC equals to CAB, and in B we are getting DAC equals to BCA. That means CAB equals to BCA. So since you see, since in this triangle these two angles are equal, therefore you know side opposite to equal angles are equal. What is the side opposite to this angle is AB, and what is the side opposite to this angle is BC. That means we can write that AB equals to BC. So we have written AB equals to or BC equals to AB. Side opposite to equal angles are equal. Again we can prove that BC, but you know that as it is a parallelogram, BC equals to AC, opposite sides of a parallelogram, so you can write that AB equals to CD from here. So in that way you can prove that all the sides of the these parallelograms are equal, hence it is a rhombus. So like that way you can prove. Okay.